So here comes the math. We are finding specific heat capacity, and here is our first example. Now, in this first example, comes directly from the quiz. So, free answers alert. It wants us to calculate the specific heat capacity of a piece of wood. 15 kilograms of the wood absorbs 67,500 joules of heat, and its temperature changes from 32 degrees Celsius to 57 degrees Celsius. All right, now as we look through this question, we're going to notice that we have some units, and that's going to help us know what to put in the equation. So first of all, we're trying to find specific heat capacity. So that in and of itself means that I'm trying to find CP. Calculate specific heat capacity. All right. That means I'm trying to find CP. So when I go to calculate it, I need to go ahead and solve for CP. That's what that's telling me. The 15 kilograms, that's mass. The 67,500 joules, that is Q. And the 32 degrees Celsius to 57 degrees Celsius is my change in temperature. And you have to remember, change in temperature is final minus initial. So my change in temperature is going to be 57 minus 32. So this is our equation. Q equals Cp m delta T. The m is the 15. That's why I made both of them yellow. The Q is 67,500. And the delta T is 67,500. Sorry. The delta T is 57 minus 32. So now when we rearrange this equation, unless I'm trying to find Q, it's going to be Q divided by the other two. So because I'm trying to find CP, the M right here is going to go at the bottom, and the T is also going to go at the bottom. All right. So remember, we said that when we are trying to get rid of something, we do the opposite. The M and the T are multiplying with C, so to get rid of them, you are dividing. So we end up with Cp equals Q over MT. Now let's remember, the M is 15, the Q is 67,500, and the delta T is 57 minus 32, which is 25. So let's put this all in there. We end up with 67,500 divided by 15 times 25. Once you put all that in the calculator, guess what you get? You get 180. All right. So that is how we calculate the specific heat capacity. It will also be how you calculate mass. When you calculate mass, it's going to be Q divided by Cp over delta T. When you try to find delta T, it's going to be Q divided by Cp and M. All right. It just depends on what you're given and what they're asking for. Keep in mind, you always get a problem where you can solve it. If I ask you to find one thing, that means you have the information for the rest. All right. Now let's do one of the harder questions, which is using the thermal equilibrium equation. This is our second example for today. Now this question reads, you would like to cool a 520 gram glass of water. What is that 520 grams? That is mass. Is it in the units I want it to be in? No, but grams is still mass. So as you can see here, when it asks for mass of water, I'm going to convert it to kilograms. All right, so let's start over. You would like to cool a 520 gram glass of water from 30 to 10 degrees Celsius. That's decreasing temperature. So your change in temperature is going to be negative. All right. If the ice you have is -5 degrees Celsius, how much ice would you need? Now, when it's asking how much ice would you need, it's asking about mass. All right. So we're going to be looking for mass. So the mass of water, 520 grams, which is 0.52. How did I get 0.52? Well, if I'm going from grams to kilograms, that means I need to divide by 1,000. Because there are 1,000 grams in 1 kilogram. All right. That's not 1,000 yet, so it makes sense that my answer is less than 1. For a change in temperature of the water, I'm going from 30 degrees Celsius to 10 degrees Celsius. Therefore, I'm going to subtract final minus initial. So 10 minus 30, that is going to be -20. Now, when you're answering the question in the quiz, what you need to notice is that I've put a negative sign for you right here, just in case you forgot to put it. I'm trying to take it easy on you. Now, the change in temperature of the ice. Now, you'll notice that there is only one temperature measurement for the ice. This is because they've already given us the final temperature. If we're going to be in thermal equilibrium, that means the final temperature for both substances is the same. So they gave us the fact that the final temperature is 10 degrees Celsius. And that is the final temperature for the water and the ice. Therefore, to get the change in temperature for the ice, I'm going to do final temperature 10 minus initial temperature -5. 10 minus -5 is just like saying 10 plus 5. And 10 plus 5 is 15. So that's how we got the change in temperature to be 15. Mass of ice needed. Now this is where it all comes together. We're going to use the entire equation CPm delta T equals -CPm delta T. Now the reason why the negative is on the right hand side is because that change in temperature is going down. That change in temperature is negative. So that's why you have to put the negative in front to make it mathematically sound. So the two negatives cancel out eventually and you get a positive number. Now, if you remember from the last video, we put the colder substance on the left. We put the colder substance on the left because this is the one that's gaining heat energy. You put the warmer substance on the right. We're putting the warmer substance on the right because that is the one that is losing energy. So take a second to think. You can pause the video if you like to. Which one is gaining heat energy and which one is losing heat energy? So hopefully you guessed right. The ice is gaining heat energy. The ice is the cold one. And the reason why we put ice in the water is to make the water cold. So the ice is actually taking the heat away from the water. That being said, the water will go on the right because the water is losing heat energy. So if we were to move this around so that we have the mass of ice, what we would be solving for is this red M right here. And how do you get that red M? Well, we have to get rid of the CP and the delta T, and they are multiplying, which means you are going to divide. So that you take that entire right side and you are going to divide it by CP and delta T. Now that we have everything all together, we just need to plug the numbers in. When you plug the numbers in, you get M equals -4186, and I got that because it tells me in the question assume both water and ice have a CP of 4186, which it may not, but for the purpose of this question, it does. The M is 0.52, which we got from the question, where it told us it's 520 grams of water. And at the bottom, we have 4186 again, because that's the CP for ice that we're using. And we have the change of temperature of the ice is 15. Did I miss anything? The delta T on top, that's the change in temperature. For the water, we established that it's -20. So you see now that the -20 and the -4186, since they're both negative, they cancel out to give us a positive number on top, which is good because we don't generally say that mass is negative. So the mass of ice needed is, if you put that all in the calculator, 0.67. And that's the answer on your quiz. That's it.